Alright, so far with electromagnetism, we've talked mostly about how a magnetic field can produce a current inside a conductor if the conductor is moving inside that magnetic field. And one prime example of that, one prime application, is that AC generator. Now, we want to flip the coin a little bit and look at the other side, and what you can do with current in order to produce magnetism. Alright, so you may recall this image from a previous video. It's called the right hand rule, and really all you do is you basically do a thumbs up sign, and that's it. Your thumb points in the direction of the current, and keep in mind that this is conventional current, so this is the direction that positive charges would be flowing if they could flow. So that basically means that this end here would be positive, and this end up here would be negative. In the polarity of the circuit there. Alright, so that's interesting and everything, but what about if you, straight wire is good for picturing it, but it's not very practical. So what engineers typically do is they'll make coils of wire, or loops of wire. So this would be one loop of wire, and you can see what's going on there. Basically, at the top here, the current would be, you have to picture this three-dimensionally, right? So this is actually a wire circle, but you're looking straight down at it, so all you can see is the top of the circle. So on this end of the circle, the current is coming upwards at you, out from the screen. So if you stuck your thumb straight out at yourself, you'd see your fingers are curling this direction, and that is the direction of the magnetic field around this end of the coil. Now on this end, of course, the current would have come out and around, and it's going back down in. So you would point your thumb in, and then you would see that your fingers curl this direction. So the magnetic field around this side of the loop goes this way, which is counterclockwise, and then around this end, the magnetic field goes this way, which is clockwise. Now at this point, you should notice that in the middle, because of the way this works, all the lines of force, the magnetic lines of force, are going the same direction through the center of this coil of wire. That's really important. That lets us set up a magnetic field in the middle of this coil of wire, or loop of wire, rather. So you may recall that lines of force come out from the north end of a magnet and go in at the south end. So since these lines of force are coming out here, you can't see the whole thing, but it would loop all the way around here and come back in. So out from the north into the south, so there would be a north end here, and there will be a south end here. Alright? Let's see what we can do if we add more than just one coil of wire, one loop. Okay, so here we have the same diagram again. Again, there would be a north end here and a south end here. Now we're going to add more loops, and I'm going to get rid, in this diagram, we're getting rid of the top of the coil, so we're still looking same view, straight down in, but we got rid of the wire. It's a cross section. Now it's a cross section through, so we've like cut horizontally. Here's one end of the loop that's coming out, and here's the other end of the loop that's going in. So we have the same magnetic field set up, and you can see that there's more lines of force. It's stronger because there's more loops. There's more loops of wire. It's a bigger coil. So this is basically, and then this is basically how you can set up a much stronger type of an electromagnet. All right. Here's another example here with a big coil of wire, and then you can see a magnetic field is getting set up. This field is opposite from this one, and then this is just a diagram of what the coil of actual wire might look like. All right, it has a name. It's called a solenoid. All right, so this is very, very much used in various forms throughout a whole lot of devices, such as drills or relays. There's lots of things that use this sort of a coil of wire. Let's talk a little bit about how we can change the strength. How can you change the strength of the magnetic field inside this coil of wire? So let's take a look at that. Alright, so anytime that you have current flowing in any conductor, you can increase the strength of the magnetic field simply by increasing the amount of current. So more current stronger magnetic field. Doesn't matter, it could be just one single loop of wire in a circuit, or it could be a whole solenoid. Either way. Now, specifically to a solenoid, there's several different ways that you can increase the strength of the magnetic field. Alright, so let's look at those. There's at least 4 of them. Alright, so if you take your solenoid and you make it more coils of wire, so here you have a thin, or a loose, let's say loose coil of wire, not very many coils, or not very many loops in this coil of wire, so that's going to have a weaker magnetic field. But then here, we've put a whole bunch of loops in there. It's very tightly packed coil, so that's going to have a much stronger magnetic field. Alright, that's number 1. Number 2, I just kind of mentioned it already. If you make the coil more tightly packed, and what do I mean by that? Well, it might have the same number of loops, but you put the loops closer together. So here, for example, 1, 2, 3 loops, 1, 2, 3 loops. Here it's more spread out, here it's closer together. The magnetic field will be stronger in this one, alright, and weaker in that one. So you can add more loops, you can put the loops closer together. What's a third one? Well, you could make the coil wider. And what I mean by that is like physically wider. So you can, let's zoom in on that. So this one, the coil is skinnier, right? It's not as wide. And then here, we've made the coil, the loops are wider, they're bigger, right? So they take up more horizontal space there. So this would have a stronger magnetic field than this one. Same number of coils, same tightness, but they're wider. So that will make it a stronger magnetic field there. And then lastly, you could put an iron core inside the solenoid. So here you've got an empty solenoid. Here we've put an iron core in the middle of it. And that is going to make a very large difference to the magnetic effect, because iron is a magnetic material, so the iron in there is going to amplify the magnetic field that's produced by the coil of wire. Alright, and just about every major kind of electromagnet solenoid combination is going to have an iron core to help make it stronger and more effective. Alright, so that is the basics of induced magnetism, induced electromagnetism, and especially in solenoids. Hope you found this video helpful, and we'll see you next time.